Okay, to help you prepare for your retakes, what I'm going to do is I'm going to go through every problem on the test A that we took. So that way, if you got your tests back or if you were looking online, you can check to see where your mistakes were. So I'm going to go ahead and start with concept 1. I'm going to work through all of the tests. So if you don't need concept 1, feel free to fast forward. If there's only one certain part you need, you have the capability to pause or fast forward on any of them. So totally up to you on what you do. When you are finished watching, I suggest that you go back and practice problems that are like the ones we've already done. Okay, concept 1 is talking about expressing ratios. So for me, as I'm reading it, I really like to point out the important information. So it says Jacob buys 17 ounces of grapes and Maddie buys 20 ounces of oranges. So I know I have 17 of grapes, 20 of oranges. Now the key really comes into play when it says oranges to grapes. You have to pay attention because the order of this is actually written from grapes to oranges, but it asks oranges to grapes. So oranges is 20 to grapes is 17. Now, if you wrote it right underneath, you wouldn't have to rewrite oranges to grapes, or you could and it would be helpful. Totally up to you. Problem number 2 says state whether 3 gallons and 5 tons would be expressed as a ratio, and then you have to prove your answer. So I want to focus on the labels and think about what I know about those. So this is, gallons is how much something can hold. That would be capacity. And tons is a weight. So even though those are both forms of measurement, they are two different kinds of forms. So here it says state whether it can be expressed. No. We have two different types of measurement. And I kind of proved that when I said capacity and weight. Okay, concept number 2 is writing equivalent ratios. It says state whether whether the ratios are equivalent. So we have two different ones. We have 13 to 15 and 30 to 26. So a thing that a lot of people want to do is they want to check the 13 to 30 and then they go ahead and they try to check the 13 to the 26. My suggestion is to go in simplest form. Any that are not in simplest form, put in simplest form, and then you'll be able to tell if they're equal or not. So 13 and 15, 13 is a prime number, and since 13 can't go into 15, we know that this one is in simplest form. So now I need to work with the 30 and the 26, and I need to simplify those. Those are both even, which tells me I can divide by 2. So I get 15 to 13. Now the first thing that I notice is that the first ratio and the second ratio given, they have the same exact numbers, however it has them reversed. So I know that these are not the same. So it says state whether they're the same. No, they are reciprocals. Okay. The next one, 65 to 90, and it's equal to what to 18? So on this one, we're finding the missing term. So I can look at my second term, which is listed in both, and I could figure out, okay, do I know how to go from 90 to 18. Remember, you get to use a calculator, so the first thing that I would do is I would check and see if I can take 90 divided by 18. I divide by 5. So I'm gonna, actually, I would probably rewrite it. I'm gonna get rid of both of those. I would put 18 down here. Now I would write divided by 5, divided by 5. And so I need to find 65 divided by 5, and that would tell me my answer is 13. So the missing term is 13. And the key there would be, if you could not go from one to the other, then again, do like you did in number 3 and put it in simplest form. So if you're unsure, if it doesn't work, you're like, I can't do this, then you should write it in simplest form, because sometimes it would be a number that 90 wouldn't go into, like 90 and 18 wouldn't work. Alright, next concept. Concept 3, simplifying ratios. It says write each ratio in simplest form. So we have 54 and we have 94. I would see what you have in common. Right away, I see that they are both even. That means they're divisible by 2. 54, I know, is also divisible by 6 and by 9. So I would check 94 into both of those. Or I would check, 94 divided by 6, 94 divided by 9. Neither one works. I'm going to go ahead and go with 2. So I divide both by 2. 54 divided by 2 is 27. And 94 divided by 2 is 47. So I have 27 to 47. Okay, number 6 is the one that really got a lot of people. Maybe I should check back with 5. Actually, when I look at 5 and I see 27 and 47, I really need to check and see if that can be simplified anymore. I know that 27 are divided by 9 and 3, and neither of those can go into 47. So I know that that one's in simplest form. Sorry, I didn't explain that before. Number 6, this is the one that tricked people. And the thing that you really, really have to pay attention to is meters and centimeters. And you want to be able to compare the two, and you want to be able to, really to do that, you need to know how much they are when they're the same. Because right now, meters and centimeters can be written as a ratio because they both are metric measurement for length. However, you need to be sure that they're the same, and so we either need to change meters to centimeters or we need to change centimeters to meters. So I've made it no secret that I like to work with whole numbers. So in this case, I'm going to change my meters, since they're bigger, to my smaller amount. So using your metric system, which was up on the board for you, the stair steps and moving, I know that meters to centimeters are 2 spaces to the right. So I get 30,000 centimeters to 15 centimeters. Now, even though that says 30,000, I immediately see 30, and I see 15, and I know that 15 times 2 gives me 30. So on this problem, I know that I can divide by 15. Divide by 15. So this becomes 1 centimeter. You can almost read that. And then the 30,000 divided by 15. If I forget my 3 zeros for a minute and just do 30, I get 2. And then I have 3 zeros left over. So I have 2,000 centimeters to 1 centimeter. Doesn't say centimeters. Okay, now if you're a person who said, well, Mrs. Dunn, I didn't move it that way, I moved it the other way, I want to show you what that would look like. So I'm going to do that one just right above. Okay, so number 6, if you wanted, you could change centimeters to meters. So if I did that, I have 15 centimeters. And I'm going to move it, my decimal, 2 places to the left. And I'm going to get 0.15, which is 15 hundredths. So if I wanted, I could say I have 300 meters. And I have 15 hundredths of a meter. Now, the people who solved this problem and did it this way, the issue that they were having, was that they just left that as 15 and they didn't make it 15 hundredths. Or as they wrote 15 hundredths above, they didn't leave it when they divided. So here you could, here you could still divide by 15. Only this time you are going to get 22 0.01. So, I'm going to circle the answers you could have had in red. I accepted either the 2,000 centimeters to 1 centimeter, or I accepted 20 meters to 1/100th of a meter. Either of those would have been acceptable. Now, the trick with number 6 is to remember you can't just divide by 15 there because meters and centimeters are not the same. So even when you do that, it's hard to know which one's bigger. Okay, I'm going to move on to concept 4 now. Concept 4 was ratio tables, and there were 2 different ones. So this one I have number 7. I'm going to tell you that your paper looked different. I've changed the problem for next time. This one, there were 13. Jessica wrote 18 thank you cards in 12 minutes. How many minutes does it take her to write 252? Yours was, I do not believe yours was 252. Give me a second. I'm going to change these. I just want to make my problem look the same as yours. You're not needing to change this because it should be accurate on yours. Actually, it might still be 252. Okay. So let's see. 18 to 12. (18 to 12) is my original ratio. I can divide those both by 6 and I get 3 to 2. So this is kind of the ratio that I'm working with. Okay, so on your paper this one was 24, 54 times 3. This one would be 48. We actually wanted to know 126. So if we were trying to finish our table, we are finding for 126 thank you cards. And I know that those are the thank you cards. So if I can either work from my 18 or from my 3, but I know that I want to make it 126. So if I work from, if I went here, this would be times 42. 3 times 42 gives me 126. And I have to do the same thing here. Oops. So if I took 2 and I multiplied it by 42, I know that I get 84. So when Jessica goes to write 126, that would take 84 minutes. Now, if you wanted, you very well could have went from the 18 to the 12. And I wouldn't have been able to go 54 times anything to give me 126. So I really either had to work with one of these other ratios. So I could have worked with the 18. I worked with all of them in simplest form, which was 3 to 2. So if I wanted, I could have really done 18 to 12, and I knew the 126. So I could check and see if 126 is divisible by 18. 18 times 7. 12 times 7 gives me 84. So either way, I get the same answer. You just have to choose what you want to divide by. Up to you. Either way. Number 8 was a big problem for the people who didn't understand it. 2 of the classes asked about this question before the test, so it made it helpful for you as you were working on it since it was fresh in your mind. This is talking about a potluck. And at the potluck, the host wanted to make sure there were enough. They knew more forks would be used. So the key with this one is to work with this ratio. And every time we're asking ourselves, how do I go from 16 to 10 to whatever piece it was giving me? So this is like three separate problems, all stemming from this highlighted part. A mistake that people make is they try to go from the one in front of them. So I am going to write it separate so that you can see really what we're doing each time. So here, if I'm going from 16 to 8, that's dividing by 2. 10 divided by 2 is 5. You could realistically, if you wanted, go from the 5 to the 30 and then do the same operation. But I don't like to do that because it doesn't always work out perfectly and then I get mad. So I would go back from 16 to 18 and I would pretend that that 5 and that 8 didn't even exist. Oops, it was 5 and 10, not 18. Sorry. And I'm going to 30. So 10 times 3 gives me 30. Remember, you have your calculator. 16 times 3 is 48. So this box, there would be, when there are 48 forks, there would be 30 spoons. Now, the problem that people had is when they traveled and they went from 6 to 8, then they tried to turn their 8/5, they knew 5 could go into 36 times. Now the problem becomes they have 320 and they try to divide it by 48 and that doesn't work out evenly. So instead of going from here to here, from here to here, from here to here, I prefer to stem everything from here. So again, I know how many forks I have. This time it's saying I have 320 forks. That is multiplying by 20. 16 times 20 gives me 320. 10 times 20 gives me 200. So here I have, when I have 320 forks, that would be 200 spoons. So again, I think the importance here is to make sure that you're looking at each individual problem. And going off, the only thing they gave us where it had both pieces was that first ratio, the 10 to the 16 to 10. If you wanted, you could have simplified it to make your multiplication problems easier, your division problems easier. So that was an option of something to do. Problem number 9. Problem number 9 is one of those real-world problems. These are the story problems. And in class, I feel like students did a really good job of highlighting important information and writing things down. And then when it came to solving the problems, I feel like we struggled. So here we say there's a charity function. They've raised $150,045, and that was donated by 3 companies, A, B, and C. That appears that it's the total. The ratio is 7 to 5 to 9, and we want to know how much A donated. So as I look back, I know I have A to B to C, and I know that that's 7 to 5 to 9. And then I'm going to take it a step further, and I'm going to go ahead and I'm going to draw my picture. And that second one should be a 5, not an 8. So I'm going to go ahead and draw my picture, and I'm going to start with my 9 at the bottom, actually. Okay, there are my 9 boxes. Here are my 5 boxes. There are my 7. And I'm going to label them so I know which is which. And I'm going to look back for this important number, and it says this is how much was raised. That makes me believe it's the total. So I have $150,045. Now, I think drawing the picture is the key. The first step was to draw your picture. The second step is to identify what's given. I know the 150,045 is the important part, and I know that it represents all of those boxes. So 7 and 5 is 12. To add 9, I just think of 10 would be 22, so 1 less is 21. I know I have 21 units equals $150,045. I want to find 1 unit, and then I can answer any question of what's being asked of me. So I'm going to divide by 21. Now remember, you have a calculator, so you can definitely use your calculator. And I get 7,145. Now that was my 1 unit. I need to go back and look what it asked for. It said, how much did Company A donate? Well, Company A is made up of 7 units. So I need to take 7 times 7,145. So Company A raised $50,000 $50,015. So I'd write that in a sentence. Company A donated $50,015. So I drew my picture. I identified what was given. I found one unit. Then I used that to get my answer. One last one. Problem number 10. Problem number 10 has two parts, and sometimes these two-part problems can be tricky because if it gives us a new piece of information, then it's really like two problems. But if we use the same information for both, then they go together. So here it says we have red ink pens and blue ink pens. The ratio of red to blue is 6:1. So this is the part that we're going to use for each of these problems. Red to blue, 6:1. So I'm going to start by drawing that picture. So for A and B, I'm using a 6:1 bar model. 2, 3, 4, 5, 2, 3, 4, 5, 6. Oops. And 6:1, red is on top, blue is on bottom. Now I want to go back, and in problem A it says there are 585 blue pens. So I need to go to the blue, and I need to write that that one is 558 pens. So right now the part that's given is 1 unit equals 858 pens. The beauty is, since that was 1 unit, the only work we need to do is multiply to figure out how many it was asking for, how many red pens. So red equals 6 units times 858. So 5,148. There were 1,548 red pens. Now the trick with the second one is to pay attention, and we're still using the same ratio. Red to blue, 6:1. I'm going to go ahead and draw the picture, but this time it gave me a different piece. Now drawing a new picture would not be a necessity, but we don't want to get confused with the numbers we used before because they mean nothing. This time they tell us we have 500 or 325 red pens. So if I label this, I know that the red pens equal this amount. So when I'm identifying what I know that 6 units equals 325 pens. Oh, we changed that one to 336, didn't we? No, we did 360, I think. I remember that this one didn't work out, so we changed it to 360. So we need to find 1 unit. And that's 360 divided by 6, which is 60. So now I need to go back and it wants to know the total number of pens. Well, total number of pens would be 6 red and 1 blue. So that's 7 units equals 60. So we're going to do 7 times 60. We're going to get 420. So it says how many total pens are there? There are 420 total pens. Hopefully after seeing the problem, it seems easier for you. Please don't think just by watching me solve the problem and solving it with me that you're now an expert. Now you need to practice it. So some options are to look back over your homework and go over any of the areas you need to. Read through your notes. There's a chapter review at the end of the book. You also could access the practice tests or the review questions. Both of those with the answer keys are posted in Google Classroom, so you can go ahead and view it there.